Hi everyone. In this video, I will explain a very good concept of three-dimensional geometry, that is shortest distance between skew lines and how to find out shortest distance line. And when a line having DRS cuts the skew lines in 2 points P and Q, then how to find the distance between P and Q. These three models are very important in JEE Main and JEE Advanced. Okay, let us start. So skew lines, nothing but they do not lie on same plane. They lie on a different planes. Two lines are said to be skew lines if they are neither parallel nor intersect. Neither parallel nor intersect. Like if you draw two lines on two different walls which are not parallel, maybe they are parallel, but lines should not be parallel. Lines should not be parallel. You see the diagram here. So two lines are said to be skew lines if they are neither parallel nor intersect. Right. So two lines are skew if and only if they are not coplanar. So see on the upper plane, I have taken one line. On the lower plane, I have taken another line. Here you see. This is one line, this is another line. These lines are neither parallel nor intersecting, and they are not lying on same plane. They are not lying on same plane. Now, how to measure the shortest distance between these two skew lines? Right? So shortest distance will be measured along the a common normal, along the common normal. If two curves are there, shortest distance between those two curves will be measured along the common normal. For example, this is the lineal. What is the shortest distance from a point P? What is the shortest distance from a point P to the lineal? So we measure perpendicular to the lineal. We measure perpendicular to the lineal. This is known as a perpendicular. This is perpendicular, or you can say normal to L. Normal to L. And this is the shortest distance from P to L. Shortest distance from P to L. From P to L. So shortest distance can be measured along the common normal of the curves. Now, consider two lines L1 and L2. Here you have that one line L1. Okay. First line passes through X1, Y1, Z1, having DRS L1, M1, N1. This is the first line. It is in symmetric form. Or we can put in vector form also. R bar is equal to A bar passing through A bar and parallel to D1 bar vector. Here A bar is the point x1i plus y1j plus z1k. D1 vector is direction ratios vector L1i plus M1j plus N1k. Similarly, I will take another line L2. Another line L2 passing through x2, y2, z2 point and having DRS L2, M2, N2. This line can be put in matrix vector form, that is R bar equal to C bar plus S D2 bar. Well, now how do we measure that shortest distance between skew lines? So the condition for that lines to be skew lines, box of C bar minus A bar, D1, D2 not equal 0. If this box is 0, the lines are coplanar. If this box is 0, lines are coplanar. Anyway, we assume that lines L1 and L2 are skew lines. Well, now how to measure shortest distance between the skew lines? See, here is the diagram. Line 1 is parallel to D1 bar, right? See, line 1 is parallel to D1 bar. Line 2, this is the line 2, parallel to D2 bar vector. Whatever we do experiment on lines, we do on their directional ratios vectors, right? And line 1 passes through the point A1. line 2 passes through the point A2. So I'll write here that this is nothing but A1 of A bar passes through A bar. And this is nothing but A2 of C bar vector. Well, okay. Now you see that shortest distance will be measured along the common normal line. Common normal line. So assume that PQ is perpendicular to both L1 and L2. PQ is perpendicular to both L1 and L2. See, PQ is perpendicular to L1 as well as L2. All right. Okay. So now PQ is perpendicular to L1, L2 is nothing but PQ is perpendicular to D1 vector as well as D2 vector. So what is the vector perpendicular to D1 bar and D2 bar? That is D1 bar cross D2 bar vector. So here this is D1 bar vector parallel to L1. This is D2 bar vector parallel to L2. Now it is perpendicular to L1, D1 bar as well as D2 bar. And this is the shortest distance SD. PQ is the SD. Shortest distance is the PQ. And this is known as SD line. PQ is called SD line. PQ is the SD, shortest distance, and this PQ line is the SD line. Okay, we'll see that. Here you see that PQ is perpendicular to L1 as well as L2. So PQ is perpendicular to D1 bar vector and D2 bar vector. PQ is perpendicular to L1, L2. PQ is perpendicular to D1 and D2. So therefore, PQ bar must be parallel to D1 bar cross D2 bar. This is the heart of the shortest distance. First point. Now, how do we measure that shortest distance? Observe that there is a point on line 1. There is a point on line 1. And there is a point on line 2. A1 is a point on line 1. A2 is a point on line 2. This is A bar. And this is a C bar vector. Well, we join these two. We join these two. It is just application of projection of a vector. Projection of a vector. Now you see, here you see the diagram. Here you see the diagram. A1, A2, right, are 2 points. It is a line segment, or you can say vector. And this is D1 bar cross D2 vector. Right, foot of perpendicular from A1 on the vector D1 cross D2 is say P, and this is Q. Now this PQ is called projection. This is called projection of A1, A2 on D1 bar cross D2 bar. So shortest distance is nothing but the projection of A1, A2. What is A1 point on L1? What is A2 point on L2? On the vector D1 bar cross D2 bar. This is the vector D1 bar cross D2 bar vector. Here, this is D1 bar vector cross D2 bar vector. So the projection of B bar on A bar equal to B bar dot A bar by mod A bar. So here, the shortest distance is equal to the projection of A1, A2 vector on D1 bar cross D2 bar. So what is A1, A2 bar vector? A1, A2 bar vector is nothing but C bar minus A bar. So we want to find out that projection of C bar minus A bar on D1 bar cross D2 bar. You apply that formula. So this is the shortest distance between skew lines. So what is the procedure of shortest distance? We can finish that shortest distance between skew lines in just 3 steps. See, L1 is a line. L1 is a line, I wrote in vector form. L2 is a line, wrote in vector form, right? Step 1, evaluate d1 bar cross d2 bar. That is direction ratios vector. Okay. Next, step 2, evaluate c bar minus a bar dot d1 cross d2. C bar is a point on line L2. A bar is a point on line L1. After that, SD is equal to ratio of this first step 2 to magnitude of step 1. This is the case. So this is the shortest distance formula. Now, one more important, how to find out that shortest distance line. How to find out shortest distance line. It is very simple. We take the general points on the given lines. We take the general points on the given lines. L1, L2 are skew lines, right? Well, now this is the point P on L1, general point. So general coordinates on L1 are x1 plus LT, y1 plus y1 plus m1t, z1 plus n1t. Well, and the general point on L2, general point on L2, that is point Q2, Q, x2 plus L2s, y2 plus m2s, z2 plus n2s. Now, this shortest distance line has direction ratios. This is d1 bar cross d2 bar. These are the direction ratios of DRS of SD line. SD line. How is PQ to this vector? PQ is parallel to d1 bar cross d2 bar. PQ is parallel to d1 bar cross d2 bar. So find PQ bar vector, OQ bar minus OP bar. Right? Two vectors are collinear if and only if one is the scalar multiple of the other, or A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Now, let us take one example. If the shortest distance between the lines is given that 44 by root 30, 44 by root 30, then what is the largest possible value of modular? Right? Very simple that you have to identify that what is the point on L1, what is the point on L2, what are the DRS of L1, what are the DRS of L2. Well, see here that D1 bar vector is equal to 3i direction ratios of first line minus j plus k. What is D2 bar vector? You just write the information. Minus 3i plus 2j plus 4k. Got it? Now, what is a point on the line 1? A bar is equal. It passes through lambda 2, 1. So, this is lambda I plus 2j plus k. What is C bar vector? That is a point on the line. Position. Minus 5i plus 4j. Sorry. Minus 2i. Minus 2i. Minus 5j plus 4k. Well, now question is so simple. You find that D1 bar cross D2 bar. D1 bar cross D2 bar vector. So this is equal to so simple that determinant of I, J, K, 3 minus 1, 1, minus 3, 2, 4. This is minus 7i, minus 6i. Well, 12 plus 3, 15 minus 15j. And this is 6 plus 6 minus 3 plus 3k. Got it? Now what is C bar minus A bar vector? C bar minus A bar vector. C bar minus A bar vector is minus 2 minus lambda into I. Well, and minus 7j. Good. Plus 3k. They have given that shortest distance is equal to 44 by root 30. So shortest distance, they have given that it is 44 by root 30. Well, so here what is the shortest distance? Shortest distance is modulus of C bar minus A bar dot D1 bar cross D2 bar. You take the cross product of these two vectors. You will get 6 into lambda plus 2 plus 105 plus 9 by magnitude of root over D1 bar cross D2 bar. This is nothing but 36 plus 225 plus 9. This they have given that 44 by root 30. This implies modulus of 6 lambda plus 126 equal to, you will get 44 into this root under value is root over 270. So that is nothing but 3 into root 30. So this is into 3. So we got that 6 lambda plus 126 is equal to plus or minus 132. Implies if you take a plus sign on RHS, you will get lambda equal to 1. Or if you take negative sign, you will get on RHS minus 43. They are asking what is the largest possible value of mod lambda. So, okay. So mod lambda is equal to either 1 or 43. So 43 is the maximum. Here is regarding shortest distance line. Well, here you see that this point lie on the line of shortest distance between the lines. This point lies on shortest distance line of these two lines. Then what is alpha minus beta whole square? So we have to find out shortest distance line. Well, procedure starts now. So what is D1 bar vector? That is direction ratios of first line minus 3i, or I'll write directly D1 bar cross D2 bar vector. This is equal to determinant of I, J, K. D1 bar, nothing but direction ratios of first line. Minus 3, 4, 2. Next, D2 bar vector. Minus 1, 2, 0. Minus 1, 2, 0. This is equal to 4. This is 0 minus 4 minus 4i. Well, and this is 0 plus 2 minus 2j. And this is minus 6 plus 4 minus 2k. All right. Okay, we got it. Now, what is the any point on L1? What is the any point on L1? You take that this is equal to T. You take that this is equal to S. Right? Any point on L1. Any point on L1. Any point on L1 is P of, okay, minus 3T minus 2. Just to do the cross multiplication. 4T plus 2. Next, 2T plus 5. This is the any point on line. Similarly, any point on L2. Any point on L2 is Q. Q, right? Q point is that minus S minus 2, 2S minus 6, and it is just 1, Z coordinate. Okay. See, PQ is SD line if and only if PQ is the SD line is the SD line. If and only if PQ is parallel to that D1 bar cross D2 bar. That is a vector perpendicular to L1 and L2. Vector perpendicular to L1 and L2. So these are parallel. So this implies. What are the DRS of PQ? DRS of PQ nothing but subtract P from Q. Well, I'll subtract. I'll subtract this P coordinates from Q coordinates. Minus S minus 2 plus 3T plus 2 whole by D bar vector component. I component is minus equal to 2S minus 6 minus 4T minus 2 whole by J component is minus 2. This is equal to 1 minus 2T minus 5 whole by minus 2. In fact, you can cancel the negative sign. For the namesake, I'll rewrite the equations. So minus S plus 3T by 2 equal to 2S minus 2T. Okay. I can cancel that 2 here. So S minus 2T minus 4 whole by 1. This is equal to, here also I can cancel. You will get negative of T plus 2 by 1. Okay. Here I will get 4. In the middle part, I have cancelled 2. At the last part also, I have cancelled 2. Now you see that you just take cross multiply these two. You will get one equation. What is that equation? S minus 2T minus 4 equal to minus T minus 2. Implies S is equal to T plus 2. This is one equation. Now equating these two, you will get that minus S. Be careful about the calculations. I do a lot of mistakes, but you should not. 4S minus 8T minus 6T. S is equal to T plus 2, substitute here. Here you will have that 11T is equal to 5S. 5S nothing but 5 into T plus 2 minus 16. Implies this is nothing but 6T. You will get this is equal to minus 6. Nothing but T equal to minus 1. T equal to minus 1. So when T is minus 1, S is equal to 1. So we got both points at which that shortest distance line meets skew lines. We got. Now substituting these points on the lines. So therefore, P point is equal to, substitute T is minus 1. You will get that 1, minus 2, and 3. What is the point Q? Q is equal, substitute S equal to minus 1 here. You will get minus 3, minus 4, and 1. Got it? Now, what is the SD line? Okay. Here, DRS of SD line are already obtained. That these are the DRS of SD line. Shortest distance line. So therefore, SD line is given by SD line that x minus 1 by minus 4, instead of that I'll take 2, y plus 2 by 1. I'm just cancelling out by minus 2. Z minus 3 by 1. Or if you take that Q point, you will get that x plus 3 by 2. There is a question in J Advanced of similar type in 2020. Y plus 4 by 1 equal to Z minus 1 by 1. Now observe, this minus 1 alpha beta lies on shortest distance line. Minus 1 alpha beta. Minus 1 alpha beta lies on SD line. Lies on SD line. Therefore, you just substitute this point on either of the SD line. You will get here minus 1 equal to alpha plus 2 by 1. That's equal to beta minus 3. Implies alpha is equal to minus 3 and beta is equal to 2. So they are asking what is alpha minus beta whole square. Alpha minus beta whole square is equal to beta whole square is equal to 25. You don't believe? There is a question of SD line in J Advanced 2020. If you want, I'll put here that question, but I won't solve. You proceed as it is. It is Advanced 2019, not 20. So here they have given line 1. This is line 1, right? And this is line 2, respectively. How is L3? L3 is a line which is perpendicular to both L1 and L2. Perpendicular to both L1 and L2, cuts both of them. Cuts both of them. The meaning of this statement is nothing but L3 is the shortest distance line. L3. This L3 is the SD line. L3 is the SD line. You proceed. Okay. Here I'll write what is D1 bar vector. D1 bar vector is minus I plus 2J plus 2K. What is D2 bar vector? 2I minus J plus 2K. Find D1 bar cross D2 bar. Well, and next, what is any point on L1? Any point on L1. Okay, that is P. It is directly there. What is I component? 1 minus lambda. What is J component? Directly 2 lambda. What is K component? That is also 2 lambda. Any point on L2? That is point Q. What is I component? 2 mu. J component minus mu. K component 2 mu. Now this PQ bar vector is parallel to D1 bar cross D2 bar. You proceed as it is, you find that lambda and mu. Here is the third model. See a line with the direction ratios 2, 1, 2. Remove that dollar sign. Okay. That dollar sign is not there. Okay. 2, 1, 2. A line with the direction ratios 2, 1, 2 meets two lines. Right? Respectively at the points P and Q. Respectively at the points P and Q. There are two questions. They can ask what is the distance between P and Q. Further, they have given that if the length of the perpendicular from the point 1 to 12 to the line PQ is L, then what is L square? Okay, it is the two-tied question. Well, we'll proceed now. Here they have given skew lines. All right. This is the line 1 and this is line 2. You take the perpendicular line. Done. This is perpendicular. This is P and this is Q. So what is the line 1? Again, I'll rewrite the line 1. Line 1 is x by 1 equal to y plus 2 by 1 equal to z by 1 equal to t. So any point on L1P is equal to, it is just t, t minus 2 and t. What is line 2? Rewrite the line 2. Divide by 2. Divide by 2. You will get x plus 2 by 2 equal to y by 1 equal to z by 1. You take this is equal to s. Right? So therefore point Q is equal to 2s minus 2 s again s. All right. What is d1 bar cross d2 bar? Okay. No. Sorry. They have given that DRS of this line. They have given already DRS of this line are 2, 1, 2. Right. So here what are the DRS of PQ? DRS of PQ. DRS of PQ are, subtract P from Q. You will get 2s minus 2 minus t. And s minus 2 t plus 2. S minus t. Right? So these are the DRS of PQ. At the same time, they have given DRS of this line PQ are 2, 1, 2. Right. DRS of PQ. DRS of PQ are 2, 1, 2. So they are in proportionate. They are in proportionate. So therefore 2s minus 2 minus t by 2 equal to s minus t plus 2 by 1 equal to s minus t by 2. There are plenty of models in J main and J advanced of this kind. Once you understand the core concept, it is easy to solve the problem. Now, our task is to find out T and S. Okay. So I hope that better you do these two equations. You will get that 2s minus 2 minus t equal to 2s minus 2t plus 4. Good. It is nice that directly we got the value of s, not s, t. 2s cancelled. Okay, this is t. So this implies t is equal to, we got 6. T equal to, we got 6. Now, from these two, 2s minus 2t plus 4 equal to s minus t. Substitute t equal to 6. You will get s is equal to, here you see that it is t minus 4. That's equal to, you will get 2. So we got the points P and Q. We got the points P and Q. But question is not yet over. P is equal to, P point is equal to t, t minus 2, t. So 6, 4, and 6. right? In fact, Q point is not necessary, but still I'll write that Q point is S equal to 2. You substitute here 2, 2, 2. They can ask what is the distance between P and Q. Of course, here they did not ask, but there are questions of this kind. PQ square is equal to or PQ, whatever it may be. 4 minus 2 whole square 16 plus 4 plus 16, that's you will get 36. So if PQ is an integer, they will ask PQ value. If it is not an integer, then they will ask PQ square value. This is one question. But here the question is entirely different. What is that question? That further, if length of perpendicular from the point 1 to 12 to the line PQ, to the line PQ. So what is the line PQ? PQ line. I'll take the point Q, x minus 2. Already DRS are given that 2. This is equal to y minus 2 by 1. That's equal to z minus 2 by 1. Z minus 2 by 2. Asking perpendicular distance from 1 to 12 to PQ line. To PQ line is equal to, they have given L. So how to find out that perpendicular distance line? Perpendicular distance, right? Here is a very simple procedure that we can find the perpendicular distance. It takes too much time. It is a 3-tier, 2-tier question. Take a line L, okay? And here the point given that, assume this is the point A, 1, 2, 12. And the line passes through the point Q, 2, 2, 2. Okay. We want to find out that length of perpendicular. This we want to find out. There are several ways to find out this. You can find even foot of perpendicular, but without finding foot of perpendicular also, we can find out the perpendicular distance. Assume this angle is theta. Assume this angle is theta, right? So here theta is the angle between the lines QA and L. We know that line DRS and QA DRS, so therefore cos theta is equal to what is QA bar vector? QA bar vector, right? Or DRS, you can say dot line DRS are 2i plus j plus 2k whole by magnitude of QA vector and magnitude of this vector, that is 9. So what is QA bar? QA bar is equal to OA bar minus OB bar, that is 1 minus 2 minus I plus 10k. So this is equal to, you will get minus 2 plus 20 whole by root over 101 into 3. This is equal to 6 by under root 101. We want to find out that what is the perpendicular distance. What is the perpendicular distance? So now cos sin theta is equal to that L by AQ implies L is equal to AQ into sin theta. That sin theta I can write root over AQ length. What is AQ length? Root over 101 into root over 1 minus cos square theta, nothing but 36 by 101. So therefore L is equal to, it is nothing but 65 under root. So this implies L square is equal to 65. From this you have learned a lot of things. Thank you for watching my channel. Keep watching my channel and enrich your knowledge.